Good day, ladies and gentlemen. Today we are looking at integration by parts for Math N6. So I started by putting on this spot everything that you need as a Math N6 student for integration by part. So you can see that integration by part is an integral of a product. That's why the formula is written like that. This formula is found on page 4 of the Math N6 formula sheet. And in that product, usually when you differentiate one item, it doesn't give you the other one. So it's your responsibility to choose your two functions, which one goes for f, which one goes for g prime. So there's this abbreviation ILATE that we always use to help any student to make sure to choose the right function. So if you have your two functions, you just need to identify whether is it an inverse function. You see examples of inverse function. Arcsine, arccos, arctan, arccot, or is it a logarithmic function? The one that we focus on for Math N6 is the lim, it must be in the form of lim. Then algebraic functions is just simple. Algebraic functions has x as the base, a number and an exponent. I always like to emphasize the difference between algebra and exponential because my Math N6 students get confused a lot between these two. You see the difference? Algebra, x is at the base, numbers at the exponent, e is a number in mathematics, I is a number that we know. Then but if you go to exponential, they interchange their positions. You see, exponential start taking numbers at the base, x at the exponent. So that's the difference between algebra and exponential. Then that is trigonometry. So whichever function comes first will depend on its position in ILATE. Then you fit it. So, that explained, this is a problem. We want to integrate x squared cos 3x. We can clearly see that this is a product. And for me to confirm that this needs integration by part, I need to look at my product. If I can confirm that when I differentiate x squared, I cannot get cos 3x. And when I differentiate cos 3x, I cannot get x squared, then this is integration by part. So all I need to do is know that this is my formula that I will use. So it's now my responsibility to choose which function will occupy the place of f in the formula and which function will occupy g prime. So in that case, I need to know what kind of function is this. X squared is like what we've got there. You see, it falls under algebra. So this is algebra. Then cos falls under. So guys, as I was saying, once we are sure that we need integration by parts, since the derivative of x squared cannot give that, and the derivative of cos cannot give x squared, we now need to choose between x squared and cos, which one will take the place of f in the formula, and which one will take the place of g prime. So that way, we need to know which kind of function is this. So x squared is an algebraic function, as we can see. I put examples of algebra where x is at the base, numbers at the exponent. Then cos x is trigonometry, as you can see examples of trigonometry. So if I go now to ILATE, I'll be looking at the letters A and T, who comes first. I'm assuming that all of us always read from the left, going to the right. So you see we have A first, before T. So the person who comes first must be F. The person who comes second will be G prime. So that's what we're going to do. So in that case, I will say let f of x be equal to x squared, and I should immediately calculate its derivative, since on the other side of the formula I need f prime. So the derivative of x squared is 2x, and I'll also be saying let g prime be equal to cos 3x. Then I will need to integrate. When I integrate cos, if you're not familiar with the integral of cos, just look at page 2 of the formula sheet. It should be sine 3x over 3, which I can also call 1/3 sine 3x. That's the derivative of cos 3x if I'm looking at page 2 of the N6 formula sheet, column number 3. So from here, I can now substitute into the formula. So if I go to the formula, it will be telling me that the integral of x squared cos 3x dx is equal to, I will look for fg to occupy that position. So fg, that's my f, that's my g. When I multiply them, I always like to put constant in front. So I will get 1/3 prime g. So where is our f prime? You see it's a 2x. Our g is 1/3 sine 3x. And I always advise students to practice keeping all constants out. If you look at our f prime g, you see our f prime g as 2x multiplying 1/3 sine 3x. So you see 2 and 1/3 are constants. So constants should be kept out of the integral because they don't affect the way we integrate. That's why our integrals end in dx. So if I'm sending out my constant, I will send it out 2/3, then I'm left with x multiplying sine 3x dx. So that's how my problem reduces. Which, if I look at this again, this is still a product where if I differentiate sine x, if I differentiate x, I'll never get sine 3x. If I differentiate sine 3x, I'll never get x. So it still reminds me that I'm still under integration by parts. So yeah, x is like x to the power 1, which is algebra. It falls under algebra. Then sine 3x falls under trigonometry. So it's still algebra and trigonometry. And if I study ILATE, again, algebra, just like before, comes before trig. So it means I still have to apply integration by part again. So for this, I will be saying, let my f of x be equal to x. Then I will immediately look for the derivative. The derivative of x is 1. And g prime will be equal to sine 3x. It's integral from g prime to g. I'm integrating. If I integrate, I will get the negative 1/3 sine 3x. So that is the same thing as negative sine 3x over 3. So I'm now going to put this information again once I reach here. So I will recopy my integral until when I reach 2/3, I open the bracket and start integrating by part again. And start integrating by part again. So I'll go back to my integral. So in my integral, I'm recopying my integral from the beginning, just as I've written before, up to 2/3. So I've got x squared at cos 3x is equal to, so I'm recopying everything up to negative 2/3 is equal to 1/3 x squared sine 3x minus 2/3, minus 2/3. Then I will open a big bracket because I now want to integrate by part again. This is the data that I'm substituting into the right side of the formula. So I have to put f and g again. So if I get back there, my f is x, my g is negative 1/3. So if I multiply negative 1/3 sine 3x to x, that will give me negative 1/3 x sine 3x minus the integral of, then again I will make f prime g into its position. So my f prime g, my f prime is 1, my g is negative 1/3. If I multiply the two, the constant will obviously be negative 1/3. So the negative 1/3 will come out and multiply here. I get negative 1/3 as a constant, which I've put outside. So if it multiplies there, I'm only left now with sine 3x dx to integrate. So at this stage, I'm not no longer integrating a fraction. I'm not longer integrating a product. This is no longer a product. I'm just integrating sine 3x, which is just like moving from here to. Sorry, when I integrate sine 3x, I think I made a mistake, guys. The integral of sine 3x cannot be sine 3x is 1/3 cos 3x, which means I have to have a relook of that. So if I look at my f g in here, my f and g is negative 1/3 cos 3x. Sorry for that. Then minus the integral of f prime g. So this is cos 3x. So that's it. So it's cos 3x. I hope I didn't make a mistake there. When you integrate cos, you get sine. When you integrate sine, you get cos. Yeah. So my substitution now should be perfect. So looking at this is no longer a product. So all I need to do is integrate this, which is like moving from here to there. So I can now open my last bracket while integrating also. So I'll get my 1/3 x squared sine 3x. If I open this bracket now, negative 2/3 and negative 1/3 give me positive 2 on 9 x cos 3x. Then you see this is already a positive. There are two negatives here, which is positive, which if it multiplies with negative, it goes back to negative 2 over 9, because we get 2 there, multiply 1, 3 multiply 3. Then I'll multiply this by the integral of cos 3x, which I should just recopy from there. When you integrate cos 3x, you get 1/3 sine 3x. So if I get 1/3 sine 3x plus c, then I can finally multiply that to see my final answer as 1/3 x squared sine 3x plus 2 on 9, 2 on 9 x cos 3x. Then now if I multiply this part, this negative, and that one will give me negative 2 on 27, since 9 times 3 is 27, sine 3x plus c. So guys, that's how simple it is to integrate a problem like that. So whenever you have algebra and trig, that is it. So one nice thing with algebra and trig by following the main method like this is that there is a second method with algebra and trigonometry. Sorry, not algebra and trig. Whenever you look at your functions and you are very sure that algebra comes first, as according to ILATE, whenever you are interpreting any function and algebra comes first before any other, whether it's algebra and trig, algebra and exponential, there is also another method of solving that, and we call it method 2, the tabular method. Or you can just call it the table method. So if I'm very sure that algebra is coming first and my target is to integrate x squared cos 3x, but I must confirm that algebra comes first. If you look at this, this is algebra and that is trig. And when you follow ILATE, let me put my ILATE there, you see that in your ILATE, algebra comes before trig. So whenever you are very sure, there is a tabular method where all you need to do is create a table. You see, this is my table. I'll put differentiation here and I'll put integration here. So the person that comes first, you put that person under differentiation. The person that comes later falls under integration. So because in ILATE, algebra is coming first, it means algebra will be here. Then the person who comes second falls under integration. So I'll call this cos 3x. So in this case, how do I handle the problem? The part of differentiation tells me where to end. So I just have to differentiate until once this part gets to 0, I know I've ended. So I'm differentiating x squared will give me 2x. When I differentiate 2x, I get 2. Then when I differentiate 2, I get 0. So this tells me where my table ends, the part of derivative. Then I will take this side, the part that came second in your ILATE, I put under integration, then I integrate it. So we've already seen how to integrate cos 3x. When we integrate cos 3x, we get 1 on 3 sine 3x. Then when we integrate sine 3x, it gives us negative 1 on 3 cos 3x. So it's like I'm getting 1 on 3. We know we don't differentiate or integrate constant. Then when I integrate sine 3x, it gives me negative 1 over 3 cos 3x. Then if I multiply these two, it will give me negative 1 over 9 cos 3x. Then now when I also integrate cos 3x again, you know the integral of cos 3x we've already seen it here. It will take us to 1 over 3 sine 3x. So it's like I have negative 1 over 9. Then I'm multiplying it by the integral of cos 3x, which is 1 over 3 sine 3x. So once I get this, it will give me negative 1 on 27 sine 3x. Then for me to say I'm done, I need to link them, the items that are right for my answer. So you link them like that and like this. So the first arrow must always carry a positive sign, the second is a negative sign, the third is a positive sign. So in this case, I will say the integral of x squared cos 3x dx is simply, I multiply the first term, which gives me 1/3 x squared sine 3x. Then the second term, you see I multiply this. These two negatives become a positive, which gives me plus 2 on 9. You see the constant there is 2 on 9. Then there is x cos 3x. Then the last term means I multiply this. The positive and the negative gives me a negative 2 on 27 sine 3x plus c. So this method, guys, does the same thing as the other method. So you see that whichever method you use, whether you choose to take your time and move gently and follow what the formula says, you see we ended with 1/3 x squared sine 3x plus 2 over 9x cos 3x minus 227 sine 3x. Then with the tabular method, it's the same thing, 1/3 x squared sine 3x plus 2 over 9x cos 3x minus 227 sine 3x. So this tabular method, I've explained it to you. For you to use it, make sure the two functions are in such a way that algebra must come first, followed by any kind of a function. So if algebra comes first, you are free to use the tabular method. So let's look at the second example and we'll see whether we can just exploit the option of the tabular method in the second example. So guys, we have, as I was saying, we have to try another problem, and as we know, we need to start by choosing the kind of functions, because here we've got x squared. If you differentiate it, you cannot get u to e, so it's negative 3x. If you differentiate this one, you can't get you there, so it's obvious that it's integration by part. So my next target is to choose my functions. This is obviously algebra, and this is exponential. So if you look at your ILATE, since we all read from left to right, and you want to check these functions, you see that algebra comes first, followed by exponential. So in that case, it's obvious that table method can work. So as I explained in the previous problem, whenever algebra comes first, you are free to go straight to the table method if you don't want to take your time and go through the normal process. So with the table method, the function that comes first according to ILATE falls under differentiation, then the one that comes later falls under integration. So I'm going to put my x squared here, then I'll put my e exponent negative 3x here. Then the function under differentiation tells us where our table must end. So I have to differentiate this side, which gives me 0. So if I differentiate x squared, it gives me 2x. I differentiate 2x, I will get 2. I differentiate 2, I will get 0. So this is where our table must end. Now this side, I have to integrate onto your end where there is 0. If you integrate e exponent negative 3x, you will get negative 1 on 3 e exponent negative 3x. Then when you integrate e again, you see you won't be integrating this one. Each time you integrate e, it keeps on giving you negative 1/3 e. So now in the next step, it's like I have my negative 1/3 that I'm not touching. If I then integrate e, it will give me negative 1/3 e to the exponent negative 3x. So if I now multiply this one out, I will get 1 on 9 e to the exponent negative 3x. Then in the last step, don't forget, we are not integrating constant. I will have my 1 over 9 there. Then when I integrate e, it will give me negative 1/3 e to the power negative 3x. So if you multiply this one out, you'll get negative 1 on 27 e exponent negative 3x. Then we'll now put our arrows as we've done it previously. This one goes there. This is my second term, and this is my last term. So the first arrow always carries a positive So finally, if I need the integral of x squared e to the power negative 3x dx, this should give me, the first term is negative 1/3 x squared, x squared e to the power negative 3x. My second term, I multiply this. You see that in the second term it will be a negative, just like the first. The first was negative because of this negative here. The next will be negative because of the other negative. So it's negative 2/9 x e to the power negative 3x. Then the last term is also negative. When you study those two signs, it gives you negative 2/27 e to the power negative 3x plus c. So guys, I hope with integration by part, in the case where the algebraic term comes first and any other term follows, I've managed to take you through. Thank you very much.